So we are going to discuss 13th group elements first. Important points from 13th group elements. 13th group elements. The first one is atomic radii orders. So here trends of 13th group elements we are discussing. The elements are boron, aluminium, gallium, indium, thallium. Coming to atomic radii, atomic radius, boron, gallium, aluminium, indium and thallium. So for this we can write some mnemonics also. Brave, Ali, gave in trouble. Similarly, big gained, always in tower. So here gallium is having atomic radii order will be reverse. Bravely, and here boron, gallium, aluminium, indium and thallium. This is the order of atomic radii. So mnemonics is big gain, always in tower. So coming to ionization, enthalpy. So here boron, thallium, gallium, aluminium and indium. This is very very important. So for this, brave thieves grab all items and melting point boron is greater than, aluminium is greater than, thallium greater than, indium greater than, gallium. It helps for last moment revision students just before exams. Electronegativity. So here big Ali tells India goodbye. Is the mnemonics to remember this. And electronegativity order, boron greater than, thallium greater than, indium greater than, gallium greater than, aluminium. These are the some important mnemonics and trends for the 13th group elements. So similarly we can discuss some more important points. Hope it is clear. And inert pair effect. +1 oxidation state. Increase, like stability of +1 oxidation state increases from top to bottom. So TL is more stable with +1. That's why TL +3 undergo, like it behaves as oxidizing agent. Oxidizing agent means it undergo reduction and converted into +1. But remaining elements like gallium, +3 is more stable. So +1 is less stable. That's why it behaves as reducing agent. These are important areas to ask questions. And coming to next one. AlF3, GaF3, InF3 are ionic in nature. TlI3, very important point. It exists as Tl +1, I3 -1. Very very important. It's not Tl +3 and 3I minus. And this TlI3 is possible. Here also Tl more stable with +1, not with +3. That is also due to inert pair effect. Tli also form. Here oxidation state of this is Tl +1, I -1. And similarly BX3. So all are covalent in nature, covalent compounds. Bi3 cannot be formed directly. And very important point here is Lewis acidic nature. Lewis acidic nature for BX3 compounds. Here X is halogen, fluorine, chlorine, bromine, iodine. So order of Lewis acidic nature is very very important. Bi3 greater than Br3 greater than BCl3 greater than BF3. So here BF3 is having back bonding. So due to back bonding, BF3 is like boron of BF3 having 8 electrons in its outermost shell. So it won't accept electron from outside. That's why Lewis acidic nature decreases in case of BF3 students. So that is one thing. Here what exactly it is, boron as like this F3. Here fluorine is having back bonding. So due to that, empty orbital of boron atomic number is like valence electronic configuration 2s2 2p 1. So over excitation you will get 2s1 2p 2. Still one empty orbital will be in p orbital. So this empty orbital electrons filled by the surrounding fluorine and neutralized as like this. So what I am telling is boron have 3 unpaired electrons. So with 3 fluorine atoms, 3 covalent bonds are formed. Total we have 6 bonded electrons for the boron. So 6 bonded electrons already there. Now due to back bonding of fluorine, the 2 more electrons shared with fluorine. That's how total 8 electrons will get for the valence shell of boron. That is how the boron in BF3 follows octet rule, so that it won't accept electrons from outside. Due to less bond length in BF3, B and F, the back bonding is more possible for BF3. But remaining cases, back bonding not possible. That's why, because of more bond length. So Lewis acidic nature order will be like this, students. Coming to the next one. So here you can see borax or diboron we'll discuss first. Most important area to ask questions in JEE exams or NEET exam. So borax is nothing, sorry, diboron is B2H6. So this can be prepared, like preparations, properties are most important. So BF3 over reducing agents, LiAlH4 or NaH, we get B2H6 along with different products like LiF or NaF, AlF3 will be formed. So similarly, even from NaBH4 we can get NaBH4 plus I2 will get H2 plus NaI plus B2H6. That's how the reduction happens for this and get the product. Here most important points about B2H6. So very very important. First, structure of diboron. So boron structure will be like this. So diboron structure. So these are terminal hydrogens. These are bridged hydrogens. So here also this. So in this case, the bond whichever is between this. So this looks like banana, so that it is called as banana bond. And we can also tell as 3-centered 2-electron bond. So how many 3-centered 2-electron bonds present in diboron? 2. So BHB, BHB. So how many terminal hydrogen bonds are there? So 2-centered 2-electron bonds. Total we have 4 students. So 4 are there. So terminal hydrogens are 4 bonds. So here these are normal covalent bonds. Because boron contain 3 electrons only, both the cases 3 3 each. So with the 6 electrons, these many bonds are formed. So middle bonds are 3-centered, means 3 atoms are connected with 2 electrons, and 2-centered 2-electron bonds are terminal bonds. Here one more very important point is these bridged bonds are perpendicular to the plane of this molecule, which means on the plane boron, these terminal hydrogens are present in same plane. This BHB bonds will be perpendicular to the molecule, means one is above the plane with 90 degrees and the other one is below the plane with 90 degrees. So these are important points. And coming to the hybridization of boron. So hybridization of boron will be sp3. So here also sp3, and both are electron deficient in nature, means B2H6 comes under electron deficient molecule. And coming to the next one, bond length. If you observe, let us take this bond length is Z, this bond length is Y, this bond length is X. Then the bond length of XYZ will be like this. X less than Y less than Z. This is the bond length order, students. So hybridization of boron in B2H6 is sp3. Both are electron deficient, so it acts as a Lewis acids. And in case of BH3, the hybridization of boron is sp2, students. And coming to the other related points for this, we can discuss. So reaction with metal hydrates. So metal hydrate react with B2H6 and get M plus BH4 minus. So here generally metals are sodium or lithium. Similarly, most important reaction we can discuss. So that is about reaction with NH3. Reaction with NH3. Here B2H6 ready to react with NH3 excess, and we'll get B2H6 to NH3, and this happens at low temperature. And same way with 1:2 ratio of NH3 and 450 kelvins temperature, we get BNX and inorganic graphite. This is called as inorganic graphite. So here, how many borons are there? Same number of nitrogens will be. This will give B3N3H6. This is B3N3H6 are formed. This is called as inorganic benzene, students. Most important, inorganic benzene. And see, the important points about inorganic benzene is same as benzene, but more reactive than benzene due to electronegativity difference in case of boron and nitrogen and hydrogen. And this is also aromatic, very important point. And this also have same like benzene structure, BH, NH, BH, NH, as like this structure will be. That's how the bond is formed. So here alternate BH NH bonds are present. These are the important points about inorganic benzene. This is also called as borozyne or borozole. And coming to the last, with excess NH3 at high temperature will get boron nitride. So this will be the general formula. This we can call it as inorganic graphite. Mostly the questions asked from this area only, so that's why it is very, very important. Inorganic graphite. And even breaking of molecule also important. Symmetrical breaking of B2H6 and unsymmetrical breaking of B2H6. So what are those that we can discuss now? These all are the important points only for the JEE or NEET exam, students. Mostly these questions only will cover, and in 2025 more questions came from this area only. Reaction with NH3 and primary and secondary amine. So here the breaking happens in the unsymmetrical manner. Unsymmetrical manner means the breaking happens unsymmetrical. Breaking of bond. So what exactly it is? BH, H. If you take this is diborane, so it will break as like this with 2NH3. So it will break as like this unequally, like this one is half, this one is one part, and this is other part. So since it is not BH3 breaking, so we are calling this as unsymmetrical breaking. So here what happens is, see, NH3 2 plus and BH4 minus. That's how the product is formed. And reaction with the tertiary amine, suppose if you take with the tertiary amine, what happens? So with the tertiary amine, just breaking happens equally. B2H6 with R3N will get BH3 and R3N, just like complex is formed. So this will form 2 moles. So we can write 2 moles means B2H6 to R3N, like coordinate covalent bond. Because amines are basic in nature, this is Lewis acid, so between them the homolytic or symmetrical breaking, and later it will be formed. And same way B2H6 with water, B2H6 with oxygen, very important compound is formed, called as B2O3 plus H2O, students. This B2O3 is used in the making of boron glassite, which is used to detect the different metal ions. So what exactly it is? Suppose if you take Cr2O3 with B2O3, will get CrBO2 whole thrice. So here, like this is called, this will give specific color. Based on the color of this compound, we can determine basic radical, like what metal present in that borax, beta, borax, metaborates. These are called metaborates. So based on the metal present in that, the color we can see. Suppose if it is Mn is present, Mn, iron, chromium, nickel, cobalt. Suppose these are the metals, and finally copper, because zinc is white color only. So here Mn will be pink color, and iron will be green color, and cobalt is chromium, right? Chromium is green color, nickel will be brown color, and copper will be blue color. Sorry, cobalt will be blue color, copper will be blue color. So copper, cobalt are blue color, and iron, chromium are green color. So manganese is pink, nickel is brown color. Yes, these are the colors for the metaborates. And here one more very important point. So BH3, NH3 with BF3. So boron have 3 bonds. So boron have 3 electrons in its outermost shell or valency configuration. So 3 fluorine atoms are like this. So hybridization is 3 hybrid orbitals means sp2. If anyone don't know how to find hybridization, you can go through the hybrid chemical bonding video. It is in the video list. And nitrogen have a lone pair of electrons. So this nitrogen give a pair of electrons to boron because it is having empty orbital. Or BF3 acts as Lewis acid, NH3 acts as Lewis base. Between them coordinate covalent bond is formed and get this compound. So we represent arrow mark from donor atom to acceptor atom as like this. So during this conversion, before formation, nitrogen hybridization is sp3. This hybridization is sp2. After making bond, this hybridization is sp3 same because total bonds. This lone pair also can give an hybrid orbital. That is why you can see if you have total 5 electrons in the valence shell of nitrogen. 3 are bonded with hydrogen as like this, and there will be one lone pair that will give one hybrid orbital as like this. So what is the hybridization? sp3 hybridization. In case of BF3, in this case, in the molecule, nitrogen connecting with 4 bonds as like this, because this is coordinate covalent bond. So same number of hybrid orbitals are formed. So that hybridization of nitrogen before and after there will be no change, which is sp3. But in case of B in BF3, the hybridization changed to sp3. That is important. So sp2 hybridization converted into sp3 hybridization, students. This is the most important area to ask questions. And coming to next one, we can also tell that CCl4 doesn't undergo hydrolysis due to absence of d orbitals. So hydrolysis happens with empty orbitals because it is an example of nucleophilic substitution reaction. So d orbitals increases, the hydrolysis process will increase. And Lewis acidic nature of BX3, we already discussed this point. So BF3 less than BCl3 less than BBr3 less than BI3. So here hybridization, boron and fluorine, valence electrons present in second shell, so that the intermixing happens between 2p, 2p. Here Cl valency configuration is 3p, so that 2p, 3p, here 2p, 4p, and 2p, 5p. So because of energy gap between p orbitals of central atom and surrounding atom, so BF3 is having same energy for boron and fluorine. So intermixing more happens here and back bonding possible more in this case. That is also one of the reason why BF3 have less Lewis acidic nature, students. So hope it is clear. And coming to the next one, borax. So borax is one of the compound. Borax is most important. Here also questions are possible to ask. Tinkal, and this is the other name of borax. And there is different type of borax. Borax glass also, which we use in the lab. So the composition of borax glass is sodium tetraborate, Na2B4O7. And coming to jewelry borax, jewelers borax. So the formula of this will be Na2B4O7 and 5H2O. So coming to preparations, not much required, just you can discuss the important points about borax. So this is just for revision class before JEE exam. So if you properly follow, it will help for your coming board exam, students. So much more important for this. Because last year 2025 more questions came from this, and most students made mistakes in this area only. And almost all papers were having these questions. So this is how the borax structure we can make. So 8H2O. Here water of crystallization for borax is 8H2O, not 10, students. While writing we write borax is Na2B4O7 10H2O, but the actual structure we get 8H2O, not 10H2O, students. And hybridization of this boron is sp2 because 3 bonds are there. Hybridization of this boron also sp2. Hybridization of this boron is sp3 because 4 bonds is also sp3. So here Na plus and P minus. So here about structure questions are possible to ask. How many borons are sp2 hybridized? 2 borons are sp2 hybridized. 2 borons are sp3 hybridized. And total BOB bonds. BOB bonds are 5. BOB bonds, you can see this 1, 2, 3, 4, 5. And total BO bonds will be 14. Total lone pair of electrons, total lone pair will be 34. So similarly, boric acid also. So very important is boric acid. So boric acid is, just you can go for next page, and boric acid H3BO3. So here Na2B4O7 over aqueous HCl will get NaCl plus H3BO3, and same way with Na2 H2SO4. This preparation is also important, so we are doing, will get H3BO3 plus Na2SO4. So this is how, and very important about boric acid is H3BO3 is weak, mono, basic, non-protic Lewis acid. Why it is non-protic Lewis acid? Basically H3BO3 we can write BOH taken thrice. So here boron makes 3 OH bonds as like this. So 3 OH bonds means boron have 6 electrons in its outermost shell, because from every bond 2 bonded electrons are there. So together 6, it needs 2 more electrons. So that is why it acts as a Lewis acid. But it is non-protic. What is meaning of non-protic? So when it reacts or when it mixes with water, so H3BO3 take OH minus from water, because it needs electrons, right? So it will take OH minus from water and get BOH taken 4 and produce H plus from the water. It's not from H3BO3. That is why it is non-protic Lewis acid, and it is weak monobasic acid, means it will give H plus ion 1 from water. And that's how the important points we can discuss for H3BO3. And finally, H3BO3 can make intermolecular hydrogen bonding, and also overheating at different temperatures. So 373 kelvins will get HbO2, and over 150 degrees Celsius will get H2B4O7. So which is nothing but tetraboric acid. Tetraboric acid. And over strong heating means at high temperature it will give B2O3. So this is also important. So B2O3 is called boron sesquioxide, which means the boron and oxygen ratio will be 1:1.5. That means 1.5 times oxygen more than boron. Those all comes under sesquioxides. That's how we can discuss all the boron and important points from 13th group element students. Similarly, we can discuss 14th group element important points also. So 14th group element important points you can see. So that's enough students now. Yes, students.